Section 1. The role of the deep learning engineer. Building intelligent systems. A deep learning engineer builds computer systems that learn from data. Think of them as architects of artificial intelligence. They specialize in a powerful part of AI called deep learning. They design neural networks. They build neural networks. They deploy neural networks. A neural network is a computer system inspired by the human brain. It learns to recognize patterns in information. The role is technical, combining software engineering, mathematics, and data science. Deep learning is transforming many industries. Autonomous vehicles. Self-driving cars use deep learning to see and understand the world around them. Robotics. Robots learn to interact with their environment. A robot might learn to pick up a delicate object without breaking it. MedTech. Medical technology. Deep learning helps analyze medical images like X-rays and MRIs. Models can spot subtle signs of disease. That enables earlier and more accurate diagnoses. One of the most powerful applications is computer vision. It teaches computers to see and interpret images and video. Engineers build systems that identify objects in photos. For example, tell the difference between a cat and a dog. In self-driving, vision finds pedestrians, vehicles, lights, and lane markings so cars can navigate safely. Another major area is speech and audio. A model converts your voice into text. Automatic speech recognition. Systems can identify who is speaking. In call centers, deep learning analyzes conversations and gauges sentiment. For text, models read, understand, and generate language. They summarize, translate, and power chatbots. A typical day mixes many tasks, but it often starts with data. You cannot build a good model without good data. Engineers collect, clean, and label datasets. Labeling thousands of images can be crucial. Data quality directly impacts model performance. Scripts automate as much as possible. Then comes building and training the model with frameworks like TensorFlow or PyTorch. Prepare data streams into the network. Training can take hours to weeks. Engineers monitor accuracy and loss. It is iterative. Experiment, analyze, improve. They tune learning rates, layers, and more to reach reliable performance. After training, testing on unseen data ensures real-world generalization. Validate performance beyond the lab. Finally, deploy the model to production. Integrate it into larger systems via robust APIs. For example, fraud detection runs inside transaction pipelines. Serving demands solid software engineering and low-latency design. In short, engineers bridge business problems and working AI solutions. From understanding the problem to data, training, testing, and deployment. Turning concepts into functional, reliable systems. To succeed, build a solid technical foundation. Coding is essential. Python is the language of choice. Master core libraries for data science. Know the math, linear algebra, probability and statistics, and calculus for gradients. Learn one framework deeply. Be familiar with the other. Use task-specific libraries like OpenCV and transformers. Practice version control, leverage cloud GPUs, and package work with containers. Start with Python, then a basic machine learning course. Build small projects end-to-end. Try text and audio projects to broaden your skills. Being great is not just technical. Teamwork and communication matter. Explain problems, performance, and limitations with clarity. Be transparent about risks to build trust. Audit datasets, test across demographics, and implement fairness metrics. In safety-critical domains, rigorous validation is non-negotiable, designed for human oversight and control. The field advances fast. Generative models and edge AI expand possibilities. New hardware enables bigger models and massive-scale deployment. Start now. Learn Python and math, build projects, communicate well, and practice responsible AI.